I'm going to do the more, I don't really know what to call it, more mathy explanation, I guess, of the proof of perpendicular lines. So let me begin by drawing out an axis. It's not really more mathy, it just, I don't really know how to describe it. It's just, I don't know. It increases the slope of mathematicians' lines faster than the other one. How about that? That wasn't very perpendicular. There we go. So we have, damn it. So we have perpendicular lines right here. And what we're going to do is we're going to say we have a point here. And we're going to drop this point down directly. So this is a straight line down to here. Oh man, I wish I'd made this longer. So this line keeps going like that. So this is a straight line. We're going to call this point X, M1. So this is our X point, and then the Y is just whatever X is times the slope. That's how we get the Y. And this is the exact same X. So the exact same X times X times M2. So the Y value is going to be X times whatever the slope is. So what we're going to do to prove that perpendicular lines are M1 times M2 is equal to -1, or whatever form you like using it. We'll just write it like in this form for now. So we want to prove this is true. And we're going to do that using Pythagorean Theorem. We're going to have our 3 points of our triangle. So these 3 points. This one is going to be, call this one O for the origin, which is 0, 0. I hope we all know that by now. We'll call this one A, and we'll call this one B. So what we're going to need to do is we're going to have to do the distance formula from here to here, from here to here, from here to here, to find out the lengths of all the sides. And then what we're going to do is then use Pythagorean Theorem. And then we'll simplify that down and we'll get our proof. So let me start with OA first, the distance, then I'll do OB, and then I'll do AB. Man, this is going to be a mess. That's why I don't really like doing these proofs. It's not that I don't like doing them, why would you do this to someone in beginning algebra? So we're going to have to do the distance formula between O and A. So O is 0, 0, and A is X, M, or we'll do the X, M1. So the distance formula is, let me write that in a different color. So the distance is the square root of x2 minus x1 plus squared y2 minus y1 squared. So that's what we've got to do. So we got x2, which is x minus x1, which is 0 squared, plus y2, which is xm1 minus 0 squared, and all of this is squared. And we get x squared here plus x squared m1 squared, square root of that. So this is the distance between OA. Now we need to do OB. So O is 0, 0. B is X, XM2. And we can just look at this and say it's going to be x squared and whatever, but I'll do it anyways just in case people aren't that you just can't spot that easily, that we're essentially going to get the same thing, except instead of x squared plus x squared m1 squared, we're going to get x squared plus x squared m2 squared, because it's basically the same thing except for this, but we'll just do it anyways. So we have x2, which is 0, minus x1, which is 0, plus squared, plus xm2 minus 0 squared. And again, we're going to get that x squared plus x squared m2 squared. So I mean, that's kind of funny looking, which is the distance between OB. Now we need to do A to B. We'll do that in, I don't know, we'll just do yellow. So A is xm1, B is xm2. So let's do the distance formula. X minus x, so x2 is x, x1 is x, which is nice. And then we're going to get xm2 minus xm1 squared, which is going to give us square root of xm2 minus xm1 squared. And we're going to have to FOIL this out, so we might as well just do it now. So this squared is, let me do it up here. I'll do it in a different color too so we don't get confused. So xm2 minus xm1 squared is equal to this xm2 minus xm1 times xm2 minus xm1. So we're going to have to FOIL this out. We're going to have to do this times this, then this times this, and then this times this times this. So xm2 times xm2, that's x squared m2 squared minus, or xm2 times minus xm1, so that's minus x squared m1 m2, and we're going to get the same thing again when we do minus xm1 squared times xm2, so minus x squared m1 m2, and we're going to get xm1 times negative xm1 times negative xm1, which is going to be positive x squared m1, or m squared 1, m1 squared, yeah. So all of this is going to go under our radical. So let me write it back in yellow. Oops, didn't mean to do that. So we're going to get x squared m2 squared minus 2x squared m1 m2 plus x squared m1 squared. And this is all under the square root, and this is the distance from A to B. Now that we found the distance, now we need to put all of these things into Pythagorean theorem. This one, so this is going to be one of our short sides. AO and AB are going to be our short sides, and the line A to B is going to be the long side, the hypotenuse. So this is the only one we got to be a little bit careful about where we place. So we're going to get, so Pythagorean theorem again, A squared plus B squared is equal to C squared. So our first side was, actually, let me write that up again. A squared plus squared is equal to C squared. I just got to make sure to conserve space because it's going to be long. So first one was x squared, and then plus, what was it? Yeah, plus x. Yeah, plus x squared m squared. Or actually, the first one's in plus x squared m1 squared. And that's the square root. So this squared plus x squared plus x squared m2 squared. And this is under square root, or radical 2 squared, is equal to this huge monstrosity up here, which is x squared m1 squared plus x squared m2 squared minus 2x squared m1 m2. And this is all under square root, and this is all being squared. So the squares are going to cancel our square root signs. So we're going to get x squared plus x squared m1 squared plus x squared m2 squared is equal to x squared m1 squared plus x squared m2 squared minus 2x squared m1 m2. So now let's put our like terms together, so we get 2x squared plus x squared m1 squared plus x squared m2 squared is equal to x squared m1 squared plus x squared m2 squared minus 2x squared m1 m2. So now you notice that we have some terms that are the same on opposite sides. We have an x squared m1 squared over here. We have an x squared m1 squared over here. So we can subtract these out. So x squared m1 squared, this is going to subtract out, so we're going to subtract these from both sides, x squared m1 squared. And we have an x squared m2 squared. And we have an x squared m2 squared over here. So we're going to subtract these out. That's going to leave us, that's going to leave us with 2x squared is equal to negative 2x squared m1 m2. And then now we divide by negative 2x squared. So divide by negative 2x squared, that's going to cancel these out and leave them as 1s. So we're going to get negative 1 is equal to m1 m2. And this is our formula. So you can see why I really wanted to make this a separate video. Is just look at all of this crap that I had to do. It's just so much. I mean, here it is in the beginning. So there it is. I hope it was worth it. I I still prefer my very barbaric explanation compared to this one. I mean, this one, I mean, if you understand math, someone can just explain the concept to you and you say, oh, okay, yeah. You just kind of just dispense with all this math because you already know that it's true. But if you want to work it out, it's a little bit of a pain. It's a bit of a hike. And I don't know. I kind of prefer the other way. The other way is very visual. Like I said, this one's very mathy. I mean, you get a picture up here of what they're trying to do. But the other method that I used, it's very easy just to see everything on a graph. And well, I mean, I just think it's much easier to explain to someone learning math than all this stuff. But if you like this stuff, you'll love it when you get to bridge to abstract math, I guess. Because that's all there is to say about this. It's if you have any other questions about other proofs, I can do them as well. But I'll just do the proofs that I think are pertinent to the class. If there are some proofs that I didn't go over earlier, but well, not earlier, but there will be some proofs that I won't go over in the class because it'll be too difficult to explain to someone who's just taking college algebra. But that's it.